Hello there, 8th graders. This is Mrs. Minowitz, and I'm here today to talk to you about weather patterns. The first thing we're going to start with is talking about air masses. So an air mass is a large body of air, and it has properties of the surface where it developed. So there are some different types of air masses, and depending on where those are formed, you're going to get some different information about them. So if you take a look, you also have a diagram of these, and we'll talk about some of these different air masses here. So M, if you see that letter, it means maritime. Maritime would be something that forms over the ocean. So if you see here, we've got M, for example, like MT here and here. These would be examples of ones that formed over water. You are going to have water that, or air mass that is, has more moisture in it, or it's wetter because it formed over water. Continental means it formed over a continent or land. That would mean that the air there is, that air mass is generally has drier air. Tropical refers to ones that are formed over the tropics. This would be warmer because it is closer to the tropics. Polar and Arctic are going to be colder. They're going to have formed over in areas or regions where it is colder in general. So if you take a look at your diagram, if we see, for example, the ones I circled before, MT, maritime, tropical, would be warm and wet. If you're looking up here, I would see CP, which is continental, and polar would be colder and dry. One word here on the difference between polar and Arctic. Polar air masses are cool or cold and dry, but not as cold as an Arctic air mass. An Arctic air mass is extremely cold, contains very little moisture, and forms at or near the Arctic Circle. Arctic would be, again, all the way up here. So depending on where the air mass formed, it's going to be a warmer or cooler temperature, and it's going to have more moisture or less. Because of this, this also tells us some things about tornadoes in the United States, and specifically Tornado Alley. So if you take a look here at these two that I have circled, and I will circle them here in red again, we have two air masses here that are very different. We have continental polar and maritime tropical. So you get cold, dry air that goes down and meets here, and you have warm, moist air from coming in here, and these two run into each other. So that is one of the reasons why we end up with this area here, kind of there, a little bit further west maybe, but kind of this region in the center here where we end up with tornadoes, and that is called Tornado Alley. Now, there are three reasons why we get a lot of tornadoes in this area. The first one is that we have cold, dry air and warm, moist air that are meeting each other. And if you see, that really doesn't happen a lot of other places on here except in the center here, and that's how we get Tornado Alley. It's also because it is between two mountain ranges. So on the west over here, we have the Rockies, and on the east we have the Appalachian Mountains. So that means that we end up with two different, kind of between those two areas. And then the other thing is that it is at a low elevation, which is more likely for tornadoes to form. So because of those three different reasons, we end up with Tornado Alley. And Tornado Alley, again, remember, is that place in the central U.S. where you end up with lots of tornadoes, more tornadoes than any other area in the world, because of these unique conditions that all occur together. One thing that we also need to know here is that weather moves from west to east. And you might think, since the Earth rotates towards the east, that our weather would come from the east as we run into it. But our atmosphere is spinning along with us at nearly the same speed near the ground. So that doesn't really impact the west to east movement. What does is the jet stream. And so we get the jet stream, that's the high altitude wind that moves west to east and generally steers our weather. So it moves from west to east because of the jet streams. It is very rare from where we are at to have weather that comes from the east. That would be something that does not occur frequently because of the jet streams. So in the winter, the polar jet stream moves south and becomes stronger because the North Pole gets colder, but the equator stays about the same temperature. This increases the temperature contrast and moves the strengthened polar front jet further south. As you probably have noticed, the jet streams are not just straight across, but have a wavy pattern. The jets follow the contours of low and high pressure areas, troughs and ridges, which move like waves in the atmosphere across the Earth. In winter, when the polar jet dips into the U.S., the troughs and ridges affect what kind of weather in the area we will have. So the jet stream actually moves depending on winter and summer in a lot of different areas, which impacts our weather a lot. Fronts. This is where we get different types of weather. Has to do a lot with fronts. So fronts are just the boundary between two air masses. It's where they meet each other. And there are 4 different types of fronts that we are going to talk about. The first one is a cold front. And you've probably heard of a cold front if you've ever watched meteorologists on the news. So when a cold front happens, it is formed when cold air catches up to warm air and slams into it. When this occurs, we get thunderstorms, heavy rain, and snow, if it's cold enough. Cool weather follows a cold front because our cold air is running into warm air, so our cool air is behind our cold front. To put this into a diagram, we have, sorry, this is cold front. We have, again, this cold air over here moving in this direction, and it hits that warm air. That warm air then rises. You get that warm, moist air rising. We get clouds forming. We get a lot more storms and precipitation. On a weather map or a symbol that you're going to be looking for is the cold front symbol. That's in blue, and it's always shown with like the points or spikes showing the direction of movement to represent a cold front. For a warm front, we have kind of the opposite happening. We have warm air that meets and overrides cold air. So this time our warm is running into cold. When this happens, we generally get drizzly precipitation. We usually don't have intense storms or severe weather. That would be much more likely with a cold front. After the front passes, we are going to get warm weather and warmer weather, and it's going to be clear. And that's again because our warm air follows a warm front. If you take a look at this on a diagram, we have our warm air over here running into our cold air up here. We get the clouds ahead of it, but that usually might bring some precipitation after it. You'll notice you don't see clouds. It's generally clear and warm. The symbol on a weather map for a warm front is going to be in red, and it's like these little bumps or half circles. Again, those show the direction that the warm front is moving as well. A stationary front is the third type of front that we are going to talk about here. These occur when pressure is equal between cold air mass and warm air masses. Stationary, if you think about like a stationary bike, it's not moving. We just have 2 air masses next to each other. We often get weather that is similar to a warm front when this happens. Our diagram here again shows, hey, we've got cold air and warm air. They're just hanging out there. They're not really, we don't have overall movement, one running into the other necessarily. On a weather map, you would expect to see kind of a hybrid symbol here that shows the warm and cold fronts kind of together. That's the symbol for a stationary front. The last type of front here that we are going to talk about is what's called an occluded front. So for an occluded front to form, we have 2 cool air masses that merge and force up warm air between them. When this happens, we get strong wind, heavy precipitation, and cool temperatures. So this is kind of similar to a cold front. Occluded fronts do not happen frequently. They're rather rare compared to our other front types. If you take a look at that on the diagram, we have very cold air that's running into different colder air, but we have the warm in the middle that is rising up because it's warm. We get some clouds, we get storms and precipitation. On a weather map, we would expect to see this symbol like this, kind of a combination again, but they're the same direction, showing an occluded front.